Hey everyone, welcome back to our Python tutorial series. Today we are diving into recursion, a powerful concept in Python that helps us solve complex problems by breaking them down into smaller subproblems. By the end of this video, you will learn what recursion is and how it works, writing recursive functions step by step, real-world use case of recursion, common recursion mistakes, and best practices. Let's get started. What is recursion? Recursion is a process where a function calls itself to solve a problem. Instead of using loops, recursion allows us to break problems into smaller versions of themselves. A recursive function must have base case, the stopping condition, recursive case, the function calling itself with a smaller problem. For example, we'll define one countdown function, def countdown, and this will take integer as an input. Inside this function, we will define the base case. If n value is less than or equal to 0, so this will become our base case. We'll write print blast off and we'll return the control. If n is not less than or equal to 0, then we will define else condition, and inside else we'll print the value of n first and we'll call the countdown function with the value n minus 1. This will become our recursive case. As you can see, the countdown function, which is already defined here, we are calling inside the same function. We'll just call the function countdown of 5. As you can see, we got the output 5, 4, 3, 2, 1 and blast off. So how it works? First, countdown of 5 is called and it will call countdown of 4. Countdown of 4 will call countdown of 3 until n is equal to 0. Recursion replaces loops in certain scenarios and makes code more elegant. Let's calculate the factorial of a number using recursion. So what is factorial? N factorial, which is nothing but n multiplied with n minus 1 and multiplied with n minus 2 and multiplied till into 1. For example, 5 factorial will become 5 multiplied by 4 multiplied by 3 multiplied by 2 and multiplied by 1, which equals to 120. We'll write that factorial program using recursion. We'll define one function factorial and it will take the value of n. As we have seen earlier, we have to define the base case for our recursive function. For our factorial, base case is if n value equal to 0 or n equal to 1. So this is our base case. What we have to do? We have to return 1. If n value is 0 or n equal to 1, we will just return the value 1. When n becomes 0, if we return as it is n value, then multiplication will become 0. So we have to define our base case here. Now in the else part, we will return n value multiplied with factorial function again by passing the value n minus 1. So this is our base case and this is our recursive case. Now we'll just call the function factorial of 5. Let's save the program and run it. We have not printed this factorial, so we'll just print this factorial. As you can see, the output is 120. Another famous example of recursion is generating Fibonacci numbers. So what is Fibonacci numbers? Fibonacci of n is nothing but fib of n minus 1 plus fib of n minus 2. For example, 0, 1 is the initial numbers, and when you add 0 and 1, we'll get the next number, which is 1. And when you add 1 and 1, you'll get the next number, which is 2. When you add 1 and 2, you'll get the number 3. And so on. So we'll write the recursive Fibonacci function. To do that, we'll define the function Fibonacci and we'll take the value of n. Now we'll define the base case. If n is less than or equal to 0, if this is the case, we'll have to return 0. If n is 1, then we'll have to return 1. And in the else case, we'll return Fibonacci of n minus 1 plus we have to add the number, so we will have to call Fibonacci of n minus 2. So this will become our recursive case. Now we'll print and we'll call the Fibonacci function with the value 6 and we'll run the program. As you can see, the Fibonacci value is 8. Recursion is widely used in real-world applications. Let's look at some practical examples. For calculating the power of a number, that is x to the power n, so we'll define the function to calculate that, and we'll take x and n. We'll define the base case. If n equal to 0, then we'll return 1, else we'll return x multiplied by power of x comma n minus 1. Now we'll just call the function print power of 2 comma 3. So this should return 8. So we'll just save this program and run it. As you can see, we got 2 to the power 3 is 8. Finding the sum of a list. So we'll define one function to calculate list sum, and it will take numbers as an input. For this, base case is if not numbers, then we'll return 0, else we'll return numbers of 0 plus we'll call the list sum 1 colon. Here we have to write list sum of numbers 1. We'll see this, what is this 1 colon, in the next sessions. Now we'll print list sum of 1 comma 2 comma 3 comma 4 comma 5 and save this program and run it. Okay, so here we have to pass it as list, so I will just put it in square bracket and run the program. We'll run the program to get the value of 15. Recursion is powerful but tricky. Let's avoid some common mistakes. Forgetting the base case. See this example. Here we have not defined the base case, so it will lead to infinite recursion. So always include a stopping condition. Excessive function calls. Slope. Let's say call the Fibonacci number of 50. In the recursion, it will be extremely slow. So we have to use some other methods like memoization to catch results. Using recursion for simple problems. Use loops when recursion is unnecessary. Awesome. Now you understand recursion, how to use it and apply it to real world problems. If you found this video helpful, give it a thumbs up and subscribe for more Python tutorials. See you in the next video and happy coding.